Hello, we are going to talk about our evidence 2 of system thinking. The team members are Javier Palacios, Karen Valdez, and Daniela Treviño.
The issue we're going to talk about is that in Corning Optical Communications, we saw the opportunity to improve the process in molding area, where it's presenting a process failure of injecting resin into the cast. The model we are going to use is the structural model. We choose this type of model we consider that is the best to improve the situation because it has a statistical technique to test and estimate causal relationship from statistical data and qualitative assumptions about the problem. This is the structural diagram where we can see the lack of interest to solve the presented issue. Didn't take the consideration to confirm the right information in the drawing, error to update the drawing in the database, lack of interest to solve the issue as soon as possible to avoid client returns, the obsolete die, no quality inspection at the end of the assembly line, and product returned by client.
Synoptic table with archetypes. The issue is injecting resin. Then the archetypes that we decide are the most relatable with the issue are displacement of the load. This means the same solutions can apply over and over. And in this case, the problem was attacked by the same solution, but it always goes back to the same thing. Then the other archetype, it's climbing. This responds to any threat in the same proportion and sense. The company always wants to be the best option in price and innovation to the clients. The next one is success for those who succeed. Give more resource to those who have more opportunities to succeed. This project was giving the resources to succeed. And then the last one is tragedy in the common ground. Everyone works for purposes that are individually beneficial. The workers on this area works individually, so no one noticed this failure.
In this flowchart, we can see in a better way the sequence of the action to solve a problem. First of all, we have to identify the problematic and then find the facts of the problem situation. After that, we find types or archetypes and then select the applicable archetypes. Identify mental model and then make a diagram with which best represents the situation. Follow the principles for system modeling that help us avoid certain situations. Then analyze and evaluate all the information that we have until this point, and with that we can redesign the system, and with this you can develop implementation prototypes.
Descriptive table. The issue is that in Corning Optical Communications we saw the opportunity to improve the process in the molding area, where it's presenting a process failure of injecting resin into the cast. The discovery of alternatives. Change the cast, change resin, change machine calibration. Development of acceptable solutions. Make test runs of the product to check in what kind of cast the issue is presenting. Make sure the cast is in condition to be used in production. Validate cast in a new, and if the cast is validated, buy a new cast. Gather and analyze of systemic information. The scrap metric is out of the allowed range. Consideration of limited rationality. The quality department doesn't know the reason of the loss in yield, and the engineering department is searching for an optimal solution to the problem.
Now we are going to talk about stages of the self-system methodology. Stage 1. Unstructured situation. Description. Possibility of improvement. Have an idea of analyze the problem. Issue description. It decides to act on the pieces that do not pass the quality standard. Stage 2. Structured situation. Classifies the information and describe the problem. Analyze the problem, identify the task performed, interview workers, and realize graphics. Next slide is rich picture. This is the rich picture. It starts with company, then engineering, process, documentation, product, end of the process, failure quality test, reprocessing, quality test approved, sent to the customer, and finally, have a satisfied customer. Continue with the stages. Stage 3, relevant system. Select the problem, define and identify the system. We use CADWO. C. Company clients. A. Engineers. T. Quality product. W. Eliminate waste of time and product. O. Molding area. E. No waste. Stage 4. Conceptual model. Define the necessary activities to achieve the improvement. Locate failure, analyze tools and process, read documentation, and get a multidisciplinary team. Stage 5. Comparison. Compare the models stage 4 with stage 2. Spark debate with the information, ask questions about the present situation. Stage 6. Settlement of change. Identify the feasible change to implement. Change the structure of the mold. This means redesign. And finally, stage 7. Implementation of change. The reaction may be immediately or maybe other problems emerge. And in the issue, this implementation was a positive improvement.
System thinking is very useful to improve the way in which organizations operate, which in most cases is achieved with the construction and use of models. The system models represent the most important aspect of the current operation. They are also a new scheme for this operation. The idea is to use the model as a vehicle for experimentation and from that to make the adjustment or to complete the design on the real situation. The model becomes a representation that can be manipulated in a much more economical, safe, and convenient way before intervening in the real system. The importance of the systemic model is a great importance in organizations, since they allow us to carry out experiments within a system to apply them to the same, solving a problem either existing or creating a new model for the solution of a part of the system. A good system modeler must have certain attributes. It must be focused and at the same time have a good broad vision to understand how the system develops. Observe how the elements that are in the system change with the passing of time. Recognize the structure of the systems, change perspective, does not research sudden conclusions, consider mental model, and consider the short and long term sequence of action and others.